There's days that everything goes great and I push a few features out and they work. And then maybe I have an interview with someone and it goes great. And I give a talk and it goes great. And there's other days that I spend the whole day trying to solve a bug and I don't solve it. And at the end of the day, I'm like a little bit drained. And I think it's important in those days to look back and think of how far you've come and the impact that you've had so far and just not let it get to you because we're all human and we all make mistakes.
Hi, Eva. Thanks for taking the time to have this conversation with me today. We discussed it earlier and how path actually crossed at the University of Surrey here in the UK. But since then, you've positioned yourself very uniquely. Your current role sits at the intersection of hardware and software. And you are working at what I can describe as the next leap in the way humans will interact with technology. So I am very confident that we are going to be having a very interesting and insightful conversation. But let's start with maybe you introducing yourself to the people listening.
Thank you for having me in this podcast, Richmond. I'm excited for our conversation. I'll start with an introduction. Like you said, I'm Eva Esteban. I work at OpenBCI as a software engineer currently. I've been with the company for around 2 years. I started out with them as an intern and then I transitioned to a full-time role. I work in the full software stack, but my expertise lies mostly in low-level code for hardware. And I also work a little bit with the business team, for example, managing the interns or running interviews with our customers.
Nice. It sounds like you're doing a lot. Like your role is just packed and you're busy. So thanks for taking the time out today to talk to me. I want to start this sort of conversation with your educational background. So what you're doing right now is pretty much at the forefront of human interaction with technology. But education-wise, how did you get here? What are the steps you took?
So I have a background in electrical and computer engineering. I'm originally from Spain and I moved to the UK to study a bachelor in electronic engineering with computer systems at the University of Surrey, which is where we met.
Yeah.
When I was doing my bachelor's, I completed an internship with General Electric Healthcare. I was working as a software engineer and intern with them for a year. And during that year, I got involved in projects that were focused on developing virtual reality applications to train doctors on how to perform certain procedures. And also I undertook dementia research project. So I was looking at how different factors affect whether people develop Alzheimer's disease or other types of dementia, like frontotemporal dementia. And this is what initially got me more interested in the neurology field. When I was there, I actually traveled to a conference to present my research, and I discovered EEG and brain computer interfaces over there. So I discovered they were actually a thing, and I became interested in this technology. I started to learn more, and I decided to come to the US to do my master in electrical and computer engineering. I did it at Cornell Tech, which is based in New York. And while I was doing my master's, one of the side projects that I did was an EEG controlled prototype for the wheel of a wheelchair for paralyzed people. And after that, I shared that project online and I got in touch with OpenBCI. I learned more about them and the rest is history.
There's so much I want to unpack there. You definitely utilized your internship, as in you went to a conference. And the reason why I'm bringing this up is because we worked in similar companies, right? In GE, I worked in G Capital, you were in healthcare, but I never heard of an intern going to a conference. As in, you definitely utilized the internship. Tell me, how was that like for an intern?
It was amazing. Actually, I was the first intern that they sent out to the US. So when I was doing my research, we realized that I had quite a few findings. And one of the best conferences to present it to was the Alzheimer's Association International Conference. And that year it happened to be in Chicago. So my manager, who has been like instrumental for me, she really taught me a lot that year. She pushed me to make a proposal to the department and ask them to send me out to the US to present this research. And I did a presentation, I explained the benefits, and they ended up flying me out. So I ended up coming here with my poster and presenting my findings. And it was great. I think that conference really changed my path because before then I didn't really know about EEG and all these biosignals. So I'm really happy that I got to do it and that my manager pushed me to go for it.
And I want to ask, what does EEG stand for?
So EEG stands for electroencephalography.
Wow, that's a
A little
mouth.
difficult to pronounce. It's basically measures the electrical signals that come from your brain.
Okay. What motivated the decision to attend an institution outside of Spain for your higher education? Why did you choose the UK?
So there were a few reasons for me to choose the UK. I think one of the biggest factors for me was the fact that the programs that I looked at in the UK offered a lot of practical courses and labs where you got a chance to build a project from scratch. So I remember in our first and second year, we built signal generator from scratch or an FM radio from scratch, and you got the chance to participate in the whole project, in the whole stack, and figure it out what you like more and what you like less. We still had a lot of theoretical classes, but I think there was a good mix and match. Whereas the programs that I was looking at in Spain mostly offered theory for the first couple of years. And I think I learned best by being hands-on and just trying different things. So I thought a program like that would help me to learn faster. Also, there were other factors that went into my decision of moving abroad. Like, for example, a lot of the research in the field that I wanted to get involved in, which was emerging, different types of emerging technology, is published in English. So I wanted to make sure that I improved my English skills and that I was comfortable enough to be able to participate in conferences and like talks. So I thought moving abroad to an English speaking country would take me get me to that level.
And which it did. And also the projects you mentioned you worked on this mind controlled wheelchair. That is very cool. How did that work?
So that's the first BCI project that I ever did. BCI stands for Brain Computer Interface. It was just a prototype that I did during my master's. So me and two of my classmates bought this Star Wars toy, which was $30 at the time because we were students. We didn't really have much money. And inside it has a NeuroSky board. So we opened the prototype up and we soldered a few cables to be able to read the data from the board. It was a toy that you put on your head and it had a couple channels to record electrical signals. And we managed to read that data and then send it to an Arduino and make a wheel spin whenever a person concentrated. So the idea was that someone paralyzed could move their wheelchair. And after that, I started building more complex prototypes. And now that I'm at OpenBCI, I have access to better equipment so I can do, better stuff.
Still sticking on the project, you worked on a trash picking robot at Cornell Tech.
Yes, that was fun. So when I finished my master's, I did research with the robotics group at Cornell Tech for a couple months. We worked on a trash picking robot. So there were two aspects of the project. One, the arm that picks up the trash, and the other one was the algorithms to figure out what was the most efficient path for the robot to get to the trash and how to detect that that was trash and not something else. So the part that I worked on was the algorithms for path planning and figuring out how to get the robot to the location that it needed to go. I enjoyed it a lot. It was a practical application, and I think they're still working on it.
That's the next question I was going to ask. All these projects you're doing, are any of them being used today?
That's a good question. I think the trash picking robot research was picked up by the next group, and it is a robot that they wanted to use at Cornell. So I think they're still working on getting it to work. So I don't think it's getting used to pick up trash yet, but I think it's getting to that point. One of the projects that I worked on in the past, which I didn't mention earlier, but I know is currently being used, is a light sensor that I developed for my thesis back when I was in the University of Surrey. So I worked on a sensor that participants for sleep studies can wear, and it records the different wavelengths of light to which they're exposed throughout the day. And it also asks them questions to find out how their sleep quality was and how they're feeling throughout the day, so that researchers can try to analyze this data and see what impact the light has on the participants. And that project I did at the Surrey Sleep Research Center, they use the prototypes to run some studies.
Right now, there are a lot of the hardware and a lot of wearables that focus on sleep data and helping people optimize sleep. Is such a booming sort of biometric to actually track and make use for people to improve their actual lives. So you were working on things that are very relevant today a few years ago, but using light is another aspect that is actually quite I've never really thought about. But what I want to actually ask is the BCI aspect of the career. So what is brain computer interface?
So a brain computer interface is a device that establishes like a communication pathway between your brain and a machine, which is usually a computer, but it can also be a robot or a prosthetic.
I was going to dive into a bit more philosophical aspect of this conversation. And I was going to ask, do you feel like the mind itself is an interface, is a brain interface, like the mind?
Do you mean to communicate with the outside
To be
world?
able to understand what we're perceiving and to communicate and our thought, the mind in itself is some form of interface that our brain has already built.
I think the brain could be thought of like that. So the brain communicates with your different organs and it takes in information from your eyes, touch, like your hands, your different senses. And then it sort of makes sense of it so that you can understand what's going on. So, I never really thought about it like that, but it is a good point.
I was just thinking about it when I was just researching about brain computer interfaces, brain machine interfaces. And I was like, this sounds like nature has already developed an interface to understand things are around. But now human beings are designing another layer on top of that to be able to get more information, internal information to then provide some form of external output in the form of actions or maybe thoughts or words or whatever form we want to put it out to. But this leads me into discussing, what does OpenBCI do as an organization?
So, but just wanted to add to your previous point that also, I guess we're trying to develop this so that we can communicate with computers or other devices that may have more external sensors than we do. So maybe robots can perceive things. Like for example, when I was saying about quantifying light, a sensor can do that. We we might not be able to do it in the same way or understand how the human body does it. And it's a good point that now we are developing interfaces to be able to have access to more information. And then maybe we might do another layer on top of that. I don't know. It's an abstract concept, but I love talking about this stuff.
It is. It is. And just to add on to it, because the reality we perceive, right, is a story the brain is essentially telling itself. Our brain abstracts the complexity of the reality around us and gives us in a form that we can actually understand and process. Or else we just have like an overload of information.
Yeah.
Our brain is doing some form of filtering. Sort of like goes into what exactly is Open BCI, where you work doing as an organization?
We are an open source neurotechnology company. So OpenBCI has been around since 2013 or 2014. And we build open source tools for neuroscience. So our goal is to make these devices affordable so that people all over the world can buy them and then research the field so that we can all advance it together. So for the past few years, we've been selling different equipment for biosensing. Most of it is headsets that measure EEG activity, but we also have other sensors such as EMG sensors to measure muscle activity. EMG is electromyography, and we have heart rate sensors, sweat sensors, etc. That's one side of the business. For the past 3 years or so, we've got involved in the virtual reality field. And our latest product that we've been working on, which is the product that I work on the most, is called Galea. And it's a VR headset that has integrate sensors on it. And these sensors allow you to measure your brain activity, your facial muscle activity, heart rate, eye tracking, eye electrical activity, and skin sweat. So we take all this information and derive different metrics to find out how people respond to experiences.
I've seen Galea and it looks very futuristic. It looks very cool. I was just wondering what sort of sparked the idea to marry VR with BCI? When you look into the space, you normally see just the headset. But what Galea is actually providing the integration of both the headset and a virtual reality and mixed reality, essentially. So how did that idea spark and what are the benefits of that?
And I'm going to try to summarize. I think there's a few factors that have played into the decision of OpenBCI going into that field. But at OpenBCI, we keep a growing list of citations where we can see what researchers are doing with our hardware. And over the years, we've observed that a lot of them were trying to merge spatial computing with biosensing. We also have been running surveys to find out what other data types they wanted to combine with EEG. And a lot of the participants mentioned things like audio or extra sensors to measure like skin sweat or facial expression. And we realized that the field is already trending in the direction of combining spatial computing with biometrics. There's a few research examples out there where people in labs have tried to combine an EEG cap and then put a VR headset on top because they want to run experiments in a virtual environment and record the data. But this solution is very expensive and it's also not replicable from one lab to another. So we decided to build a product that can be standard across all labs and users, and that already provides people with the data integrated and synchronized, time-stamped, so that they can use it for their research. So basically, Galea is the way that we have to solve the problem that a lot of individual groups are trying to solve by themselves.
That is a very large task to take on and in a field that is just emerging, right? So what OpenBCI is trying to do is create a standardized sort of platform that can allow for everyone to essentially create. You focus more on the creation of application as opposed to trying to clean data and make sense of the data that you're actually getting as an output. There are a couple companies that come to mind, right? When you think about BCI, at the top of the list is Neuralink, right? Neuralink made BCI, brain computer interfaces, cool. It put it in the front line of the media, even though it has been in the spotlight. Elon Musk has his own sort of like following and charisma and is brought it within the space. What are your thoughts on invasive versus non-invasive approaches to BCI? As in, why would you favor one over the other?
Personally, I think both have a place in the world. I think they're complementary, so I don't see them as mutually exclusive. Invasive BCIs have a higher barrier of entry for people to wear because it's more risky to get an invasive BCI implanted and they're usually more expensive. But on the other hand, they have higher spatial resolution because you can put a lot of electrodes in and you are working close to the internal parts of the brain. So you're able to get data that is much cleaner and of a much higher resolution. On the other hand, non-invasive BCIs are cheaper and anyone can put one on their head with no risk. Like I wear one every day. So I think it's much easier for people to acquire and become comfortable with them. But they have a lower spatial resolution because there's only so many electrodes you can fit on a scalp. And also they're more noisy because you have the hair. And when someone moves, it's hard to secure them on the head. So I think both technologies have pros and cons. And I think right now, non-invasive BCIs are easier for consumers and people around the world to start wearing regularly. So I think they will become popular first. But I think in the future, once invasive BCIs are more advanced, they will probably become more popular once it's less risky to get them. And, maybe in the future, we will all be wearing a chip in our heads.
You say in the future, how soon could you put an estimate as in you operate within the space? How soon do you feel like we might be going there? Well, actually, let me ask the first question. How soon do you feel that the non-invasive or BCI devices like Galea will become commercialized? How soon do we see that being used in everyday life?
It's hard to estimate, but I would say for research labs and companies, for example, they are already being commercialized and used. I mean, we have people who are using Galea right now to run experiments, but not individual. I would imagine for individual consumers, it's harder to get their hands on products like this. So I think in terms of research companies and big institutions, they're already starting to acquire them today. But if you're talking about someone wearing a BCI out in the street, I would probably give it maybe like in, from now to the next 10 years or something like that.
Okay. And do we put maybe another 10 or 20 years for invasive? Or
I would like to.
are they going to move in parallel? Because I think Neuralink is going to launch something maybe next year. I'm
I
not
think
sure.
they'll probably move in parallel, but I think people are going to be much more skeptic of getting an invasive BCI on them. So I think that'll probably delay the acquisition of those systems. We actually ran a survey last year, which was really interesting for me to find out what people are concerned about when it comes to devices reading their brain data on a day-to-day basis.
Yeah.
And it turns out that I think it was like around, we had like maybe 600 something participants from the US, and about like 70%, if I'm not wrong, were like open to trying this technology, but they were also the 70% concerned about things like people stealing their data or selling their data, mind control, getting hacked. So those are things that we need to address. And I think with a non-invasive BCI, if the person is feeling uncomfortable, for example, they can just take it off and like decide not to use it until they completely understand what's going on in the background. But with an invasive BCI, once you have it on, you have it on. So I think people are gonna need much more reassurance
Yeah.
before going down that path. But it's hard. It's hard for me to estimate a number of years. I would love for everyone to be wearing this technology in like 5 years, but I think we need to make it much more comfortable and sleek.
And sleek. Yes.
Yeah.
Yes. As in, talking about sleek, there's another company that I came across that has a futuristic looking headgear for BCI, and it's called Kernel. Have you heard of Kernel?
I've heard of Kernel.
Their one is very sleek, like metal. It looks very shiny, but it doesn't have the integration with virtual reality sort of device. And I think they're focused on just imaging essentially. The co-founder of the company is called Brian Johnson. He was on a podcast just talking about what they're working on, and it seemed very more focused on the imaging of the brain and understanding the signals. I started to think about the applications. Then when thinking about the applications, I came across another company, BlackRock Neurotech. So they are actually using this brain computer interfaces to help people with some neurological disabilities such as paralysis. And they're using this brain signals to actually control robot arms to conduct day-to-day activities. So that is direct application. Have you come across BlackRock Neurotech's technology?
Yeah, I've seen what they built, and I think it's amazing. Last summer, we had an intern working here, and now he's working at BlackRock Neurotech. So he tried out non-invasive, and now he's trying out invasive. And I think it's great. I think the advances that they are making are very promising for people that are paralyzed or that have had, some sort of accident or a condition. So I'm excited to see what comes for them in the next few years. And I think obviously in the medical field, barrier of entry for people will be lower because they need help. So I think they're more open to testing out a device like this. It has the potential to give them a huge benefit.
Yeah. As opposed to entertainment, we'll probably see more applications in the medical sectors first. And I think companies like OpenBCI are trying to move brain computer interface utilization away from the research more into the hands of right now developers, then later on consumers.
The main thing that we try to do is build the device. So we build like the mechanical, the hardware, firmware, software, and an SDK that has examples on how you can start developing applications with this. And then we sell it to researchers, companies, or individuals so they can start creating things in their own field. And I think that in this way, we have a much bigger impact because then we can target like the healthcare field and the gaming field and entertainment. And it'll just spread out. People will start working in their own domains and they have much more expertise than us in those domains. So I think it's a nice way to move the field forward by just providing the tools and having people use them where in the field that they're experts in.
From a developer's sort of perspective, what programming language can I use to interact with both the hardware and the software using the Galea, the GUI, the OpenBCI software GUI?
So Galea has a software package that comes with it. And it contains the OpenBCI GUI, but also examples of how to use the data provided by the GUI in Unity. And we're planning on also doing Unreal because Galea is based on virtual reality. You would probably be using either Unity or Unreal. But the library that we use to communicate with Galea and with any other OpenBCI products is called BrainFlow. I don't know if you're familiar with it, but BrainFlow is a library based on C++ that has support for multiple other languages like Python, R, MATLAB, Julia, I think. There's like a full list of languages that have support for the library. So if you wanted to use MATLAB, for example, to read the data and just run your own experiments, you can.
So I can literally get my hands on this Galileo headwear that you're going to send to me after this conversation and just use Python to find some form of a way to sort of marry some of the computer vision knowledge I know with a bit of the sort of like brain activity. Is there a price point that you can share of this headwear, of this headgear?
Yeah. So right now we are selling the beta Galea devices, and we actually closed the first batch of devices
No.
like a couple days ago. So we are opening up the second batch, and the price right now is $25K, which is compared to other OpenBCI products. You might be asking yourself, it's more expensive, but it's also a high end product that we've developed from scratch, and the technology is very complex. So it's like a whole different beast compared to the other products that we've been selling over the years, which are more like 3D printed and hacky makey for people to get started fast and be able to combine them like Lego blocks.
Yeah, and 25K will put me out of pocket at this moment in time. I'm guessing there is some internal efforts to bring this down. Is in how does reducing the cost of the headgear, what does that look like? Does that look like mass scale? We're getting sort of more people buying the product, hence you can maybe develop more, or does it look like reducing the cost of individual components within the headgear? How do we get to that commercialization?
So for now, initially, we are targeting mostly institutions and research labs for the headset. First few units will be used by companies, for example, in the gaming space or by research lab investigating different conditions like ALS or the stuff that you mentioned earlier. And I think once we've run the beta program, we will probably learn with the feedback that they give us and incorporate it so that we can make it a device that is more accessible to consumers and other people.
Okay. And I want to talk about more of this, the data side of things and about your role. What does your day to day look like within Open BCI? What does it, you sound like you're busy, but what does it actually look like?
So it changes quite a bit from day to day, but I would say a typical day for me probably starts with the software stand up. So the software team have a stand up every morning and we discuss what we're gonna be working on for the rest of the day and what we did the day before and bring up any blocking items. And then we each go off to do our tasks. I would say like 60% of the work that I'm doing right now is development for the firmware for the next version of Galea. So I'll be coding in C, C++, and like bashing my head against the wall when it doesn't work. But usually it does work. And then in the afternoon, sometimes I get an opportunity to work on side projects. So, for example, right now I'm working on a drone project where I want to control a drone with Galea and be able to see the feed of the camera on the drone inside virtual reality. So it's one of the things that I work on usually at the end of the day when I'm done with the firmware development. But other days I'll be, for example, running user interviews because we try to stay very close to our customers and find out what they like about the products, what they don't like, so that we can incorporate that to the next versions. And I like doing that a lot. So I'll have, maybe like 2 or 3 calls a week where I can get some of this feedback and then bring it back to the engineering team so that we can take it into consideration when we're deciding what features we're going to add.
Okay. So if I take it from the last thing you said, what type of feedback do you commonly get from people that try out this early stage form of technology?
So we get feedback on different parts of the stack. I would say one of the most important ones is how comfortable the devices are and how well the mechanical prototypes are made and how well they adjust. So customers will usually tell us like how long they can wear it until they start, to feel one of the electrodes, what felt comfortable, what didn't. And then also if they have any problems with the software when it comes to installing it, or if there's any features that they need to use for the research that they can't find in our current software, they usually bring it up and I can make a note and then we can discuss in the engineering team whether that would be a good thing to add or not.
And one thing I was going to ask on a more personal level, within this space, right? What part of this technology do you see yourself using on a day to day, whether invasive or non-invasive? What part of your life do you think BCI will be most useful?
For me personally, right now, I do use BCIs to track my meditation. So I've been meditating for like 6, 7 years on and off. I don't always keep up with it every day like I would like to. But one of the first projects that I did in the field was build a meditation tracker for myself to find out if I was staying relaxed for longer periods of time as I practice more and more. Oftentimes I wear a headset and I'm working on these side projects to try and quantify whether I'm getting better at meditating or not. So I think that's one of the applications that this technology has that benefits me in my daily life.
I want to talk about the actual practical use of like actual hardware, right? It's quite physical. It's quite on your head. How long can you wear the headset for before you start to notice you're wearing something, especially if you're meditating?
So Galea, for example, people can wear it up to like, I would say like an hour comfortably right now at the state that the prototypes are in, the alpha prototypes. And the beta prototypes are going to have a different mechanical design, which is going to be much more comfortable because we've collected a lot of feedback from alpha users over the past couple months. So I think people will be able to wear it for a few hours with no problem,
Okay.
which is, enough for a research session, experiment. And yeah, usually that's how long people wear it for.
How do you make a device like that more comfortable in terms of the electrodes?
So there's different things you can do. One of the things we did with Galea is that the electrodes that we use on the back of the head and the midline are flexible. So previous OpenBCI headsets had rigid, dry electrodes, and Galea has a new version that we developed in-house for it to be more comfortable, which is flexible. So you can barely feel it, and it gets through the hair much better. I can wear Galea and get signals with no issues, and I have pretty long hair.
Is it
And then other things you can do is, for example, make different sizes for different sizes heads or shape them depending on the person's head. So some people have more like elongated faces, others have like longer on the back. And we've been collecting this sort of information for many years because of all the headsets that we've been developing. So we're able to make headsets that adapt to different sizes and shapes.
in terms of where you were or where you are now, you're pretty much very integrated into OpenBCI. You've been there for 2 years. You work in software, hardware, and you work with the interns and you work with business as well. So you're working across different departments. But you started off as an intern.
Yeah.
What did you do that made you sort of like stand out for the people at OpenBCI to decide to take Ava from an intern to a full-time employee?
So I started out with them as an intern. And the plan was that I would be an intern for 3 months and then they would decide whether they gave me a full time role or not. The pandemic hit in the middle of that.
Excellent.
So that was pretty stressful for me, but I knew that I wanted to be at OpenBCI. Like it was a company that I was the most passionate about. So as soon as I joined them, I started building things straight away. And I think one of the things that I did that they liked is that I came up with a few small project ideas for myself to do. And I just like grabbed the equipment and built them and would push out tutorials on how to do, for example, like a presentation that you're moving with blinks instead of using your mouse, or how to scroll through a website using EMG so that you don't have to touch the keyboard. And I started doing these small projects and then making tutorials and putting them up on the OpenBCI website so that other people could see how many fun things you could build with our equipment. OpenBCI is a company that takes a lot of pride in their documentation and their community. So I think that my drive to make the community interested, together with the fact that I could just come up with ideas and do the full stack, like the hardware and the software, I think that was a plus. I don't know, you probably need to ask my team, but I feel like that made an impact on the team. And also, I always made sure to show how passionate I was about the company and how I aligned with their values.
Okay, so I want to talk about the values of OpenBCI, right? In this day and age, AI can be, it's pretty much neutral. It's a technology and you can use it for either good or somewhat evil, depending on whatever hand it falls on. At OpenBCI, you're creating a technology that can be essentially, could be used to sort of maybe control militarized drones, right? This is a reality that we have to be very aware of. So what are the values that OpenBCI currently have?
So I would say the first value that the company has, which is in the name, is that it's open. So open source. We make technology open source because we think that's the best way to advance the field. And when I was looking at companies to work at, OpenBCI stood out to me because the fact that they make like the hardware and the software open source for the sole purpose of advancing how much humans know about neurotechnology told me that everyone that works at the company has the same goal as me, which is to push this field forward as much as I can so that we can improve people's lives around the world. So that's one of the values that I really like about the company. And another thing is that we're very careful with consumer data. So when you buy a OpenBCI product on the store, like for example, an Ultra Cortex headset or an EEG cap, and you connect it to the software on your computer, the data only gets stored locally and we don't have access to your data. So only the consumer has access to their data. And I really like this approach because it keeps it secure and it helps people to understand it, exactly what's going on and where the data is going. And we definitely want to keep the trend of using this technology for good. So to make sure that it gets used in an ethical way and that we're going in the right direction, we have been running a bunch of surveys to find out the concerns that people have with this technology. And we take this feedback and incorporate it into our product development so that we make sure to be transparent. And for example, some of the answers that we get is that people are worried about like selling their data or getting their data stolen or mind control. So by knowing these concerns, we can make sure that we are transparent with them on what's happening in the background so that they can understand that no one is going to steal their data. And I really like the transparency of the company. I think the CEO of OpenBCI, Conor Rosamano, stands by these principles and his mentality just like spreads down throughout the company. So it makes all of us motivated to follow the same principles. Like we're all good people
Yes.
and looking to push this field forward and make an impact. So I love the vibe and it keeps me motivated on a daily basis. So OpenBCI has a community page and we keep it updated. A lot of our users post the projects that they're working on that page. And it keeps us motivated because we learn about what people are doing with our equipment and we see the crazy stuff that they build and how useful it is for them. And it also helps people to connect with each other and find people that have similar interests so that they can bring both of their expertise together and build something that would be better than what they would do individually. So I really like the community aspect. And at OpenBCI, we do put a lot of our time into building this page and also making sure that we push content out there that is going to help people to build their projects and connect with others that have similar interests.
M-
So it feels like a big family. Make it happen. That's how it feels to me.
The thing I was going to actually talk about, the weird thing was about the projects that
Cool.
you're seeing. What's the weirdest projects that you've seen? And I can give you an idea of a project that I think is weird, but not too far-fetched.
What's the idea?
It's sort of like a 4D, 5D cinematic experience where you get to wear the headgear and you're watching a movie. So you can hear the sound, you can see what's going on in the movie, and maybe you can maybe feel some chair movement and wind movement. But now, during the recording of this movie, the directors and the writers have simulated the brain signals that they want the viewers to feel in certain scene. And you put on this headgear, invasive or non-invasive, while you're
Mhm.
watching a movie, and it synchronizes with the movie, and you start to feel what certain characters are feeling, giving you like a 5D experience of a cinematic experience. What do you think? Should we work on that?
That's crazy. I would love to experience something like that.
So
I think in the future, we will be able to do things like that, or I hope at least. That's a pretty crazy idea. I don't know that I've seen such crazy things, but I have seen a project that really stood out to me where researchers used electrodes around the mouth of someone and that person could think of what they wanted to say, but without actually saying it, they would just think it, which would provoke micro movements on their mouth. And then the researchers could decode these micro movements into what they were actually trying to say. It's not EEG or brain stuff, it's muscle, but it blew my mind, especially because I think of the implications that it could have for someone that is not able to communicate
that
and
is
how it could change their life.
that is very useful today. That is more useful than the cinematic experience idea that I had. So
In terms of futuristic ideas, I'm really interested in learning about how we can provoke experiences to people, like you said. Like if we can tap into the different senses that we have, like vision, smell, touch, and stimulate the nerves that those signals, which is something that I'm pretty sure we will be doing. Then maybe we can provoke certain sensations.
The headgear sounds very versatile, right? Not only can you get the electrical signals from the brain, but you can get muscle movement and you have hit sensors as well. That's a lot of data. So the question I want to ask is, what difficulty have you found dealing with that much of data?
So in terms of dealing with large quantities of data, I think the main obstacle remains how to make sense of it. So obviously cleaning the data and storing it are problems or obstacles that you need to face when you deal with large quantities of data. But I think there's a lot of tools to do that nowadays. But I think a problem that a lot of companies, not only OpenBCI, is trying to solve is how to make sense of all the data coming from the brain and other muscles and translate it into quantifiable metrics, such as, for example, say being able to say that the person that's wearing the headset right now is stressed or is concentrated on this one object on the screen or is enjoying the experience or is not enjoying the experience and we should give them another experience. And for that, there are different technologies available, like, for example, training machine learning models or deep learning networks. But I think it's a very broad problem that we are all trying to work on. And it's one of the things that I'm the more interested in doing is figuring out how to make the data quantifiable and useful for the consumer. A lot of people that use these devices are not that interested in the raw data. They just want to find out, is the person happy? Are they stressed? And it's a pretty complex problem to try to quantify this, especially for different people, because we're all different. We have different brains.
Sounds like a very difficult task. What areas, if I was to, let's say if I wanted to develop like an algorithm that could process this data, what sort of topics and areas would I need to be researching?
I think you would need to look at obviously data science, machine learning, deep learning. These are really big and complex areas that a lot of people are getting into right now. There's quite a bit of papers from researchers that are trying to solve this problem or smaller parts of this problem, which I think are really interesting to read because there's people that have acquired accuracies of like 80% in being able to discriminate between different mental states. So we as a collective, the neurotech field has solved some of these smaller challenges, but we still don't have like a standard way of providing these insights.
Okay. As in, I'm going to move into more sort of a fun question. As in, what the questions I've been asking are fun, but it's a funner questions. So I'm gonna mention a series of movies, right? And these movies have not OpenBCI, sorry, BCI technology within them. So
I'm like, have we been featured in a movie?
not yet, not yet. So let's go. So we're gonna go with the first one, and you just let me know if you've watched it. Ready Player One?
Yes.
Nice. Matrix.
Yes, I watched it.
All four?
No, I think I only watched one.
What? No,
Yeah.
there's three more you need to catch up on. Update.
Update. I haven't watched that one.
Why?
Write it down.
It
About.
came out in 2018. Very low budget movie, but very well done. Very well done. It beats most of the high budget blockbusters movies. It's very good.
What is it about?
This guy has a paralysis from an accident. Then it gets invasive brain computer interface put into him called STEM. And he suddenly can walk and fight and whatnot. It's an action movie. So he goes crazy with it. The key part of the movie is the interaction the main character has with STEM, the brain computer interface, or the AI within the brain computer interface. And it's just funny to see the two interact and they almost argue as to what to do next and who's in control of the body. And it's maybe foreshadowing of a future that we can have with this internal battles within ourselves we have with AI, voice assistants or something. So it's a very, very interesting movie. Done on a low budget but very good. It's called Update.
So the interface itself is like an AI
It's like an
that
AI.
can decide or at least provide ideas of what to do. That's
Yeah,
pretty.
it provides ideas, and sometimes it asks for permission to take over the entire body. And then it
That's
just,
pretty cool.
does that future sound possible? As in, what the tech is, the brain signals. Do you think if we were to visualize into the future, that is possible?
I don't know that you could have. Well, I mean, I was gonna say that it seems pretty unrealistic to me, but at the same time, AIs are getting more and more intelligent, and brain computer invasive brain computer interfaces are getting more and more powerful. So I'm scared of saying that it's not possible and then it happening at some point in like many,
Next,
many. I've been surprised by technology many times. Like even what I do today would seem impossible to me when I was doing my undergrad, because obviously I didn't know about the field. But if someone told me that I could wear a headset, like I did this small project in my free time, which is an electrode that I can put on the back of my head. And when I close my eyes, it detects that the brainwaves associated with sleep and closing your eyes are peaking. So it turns my bedside light off so I can sleep. And if you had told me that that's something that I can have at home and that I can build easily with an Arduino today, I would have been like, you're crazy. But it is. So
that's pretty cool.
I don't know where the limit of technology is, honestly. And I like to keep keep the brain open to what might happen.
To the possibilities. Yeah.
Yeah.
As in right now, what we're doing in BCI is data collection and making sense of the data. Eventually, we'll be able to have, once we have the data collection down, as in we've got that ticked off, we're able to integrate other forms of technologies within this BCIs, which could be some form of AI assistant. The same way we have OK Google and Alexa on our
Yeah.
phones, and now we can just ask for the weather. We can somehow have that integrated into these devices that rather than actually speech, we just send neural signals, electrical signals to your auditory cortex, which then simulates, like it emulates speech essentially. Anyway, it's sort of like a weird feature that we can imagine.
It's not that weird, honestly. I think in the future, we're going to be walking around with EEG systems, BCIs on our ears or like maybe the back of the head, something minimal and connected to our phones. Like I see that as a realistic possibility. We already use biosignals, like you use your fingerprint, for example,
Yeah.
every day, and that's a biosignal. And I know there's companies out there that are developing a brain ID where they're able to tell that the signals are for your brain, from your brain and your brain only, and that's your ID instead of a fingerprint.
Wow.
Yeah, I've read of some research on that. It's pretty cool. So I don't think what you're saying is too far, to be
Yeah,
honest.
I wonder how that would work for, let's say if you have like a twin, we have like the same similar brain ID, and then probably not, because every human is unique. But at what point does this technology begin to change what makes us human? Do you see some segment of humans equipped with AI assistants that make them seem super smart, right? So right now, you can ask me a question that I know nothing about within your space, but I can just search and give you an information, and it might sound like I know something about this topic. Now, imagine we take the phone, Google, and we put it in my head, and I can access it through this brain computer interface AI, and it provides me this information. At what point do you see that world happening first? And doesn't that separate humans? Because there might be humans that seem super intelligent, but it's just you're accessing Wikipedia through your brain.
Right. I think this is a great question, actually. I like that concept a lot because the direction that I think we're moving on is carrying the computer on us. And if you think of it, Galea is a platform that allows you to have like some aspects of the computer on your head like you can experience a virtual world, and you're getting all this data collected from your own head, which then is impacting what is shown to you on the screens. So the goal, if we look into the future, like years from now, is to build like the operating system of the mind and build like a computer that we can carry with us that can expand or extend our senses and provide us with abilities that we don't have naturally, but that technology has the ability to give us. So what you're saying could be one of those abilities. Like right now, you interface with your phone using your hands. But I think in the future, we won't need keyboards or controllers to interface with technology. An example that comes to mind right now, I don't know if it's a bit of a tangent, but I know Meta, the old Facebook, they're working on an EMG wristband that allows you to type without having a keyboard and to control a computer without having a controller or a mouse. So I think that's the trend that we're moving on, like carrying the technology on us and being able to interact with it with minimal effort. So I don't see what you're saying as something impossible. It's basically like having Google on you and being able to transmit the information to the browser with minimal effort. And in terms of whether it would provide advantages to some people, I think that we could potentially compare that to other things that some of us have access to right now that other people don't. That the world, a lot of people have access to different kinds of education, depending on how much financial freedom they have. They can access different healthcare options or different devices, even like the phone that you can use, the clothes that you can wear. So I think this would probably could be comparable to like something like that.
Yeah.
You
And
get what I mean?
it feels like the gap in intelligence that it will place at human beings with and human beings without this device will be so massive that you will probably not want to interact with human beings that can't basically communicate at the speed at which you're thinking or which you're able to process and get information. You might think you're like a higher human than them. And if now the technology costs 25K, in the future, that technology, if it's not commercialized, might be very expensive and it's only maybe rich people or financially free people that can afford it. It's a bit of a dystopia.
I think it's definitely something to take into account. And I think that's why we need companies that try to like make the products affordable, or at least try to build versions of them that will have maybe a couple less features but be accessible for more people. So I
Yes.
think every company working in this futuristic space has this dilemma of, okay, the technology is very complex to build and it has to be high end, it has to be safe and secure, and this costs a lot of money. So we need to set it at a high price, but at the same time, we want as many people as possible to have access to it. So how do we lower the price? And I think this is an ongoing problem that we are working to solve. And it's important to bring up the things that you said in discussions so that everyone can have it on their mind and try to make sure that we do as much as possible to bring
Yeah.
this technology to as many people as possible.
It might take a different turn and be more like mobile phones, where at first you only have the rich people in society or people that working in corporates had the massive, you pull out the antennas and massive cellulars. But now having a phone is so like driven. 8-year-olds,
Yeah.
6-year-old kids have phones, even younger than that. So hopefully it goes in that direction. And let's take us away from this weird future that I'm trying to paint. And let's come into today. I want to talk about mental health, right? And you as a person. So you work in a highly technical field and it's pretty much at the cutting edge of technology. How do you cope and deal with stress?
So I do experience stress. And I think over the years, I've developed a few techniques to deal with it. One of the things that I use a lot is meditation, like I mentioned earlier. So in the morning, I try to meditate for like 10, 15 minutes, and it helps me to clear my mind for the rest of the day. I think after doing it for a few years, it's definitely had an impact on how I come into work and how I perform for the rest of the day. Another thing that I use is exercise. So exercise for me is like a huge outlet. And I'm actually training right now to run a full marathon, which is turning exercise from being an outlet to actually being like a second full-time job. So I'm not sure how much stress it's reducing or adding at the moment, but up until I started running the longer distances, I used to exercise a few days a week, and it helped me. I mean, it promotes serotonin and it makes you feel great in general. So it helped me to lower stress. And I also just try to think that I'm doing my best. So every day I try to learn new things and make sure that I contribute to the company in a positive ways. But obviously everyone has good and bad days. There's days that everything goes great and I push a few features out and they work. And then maybe I have an interview with someone and it goes great. And I give a talk and it goes great. And there's other days that I spend the whole day trying to solve a bug and I don't solve it. And at the end of the day, I'm like a little bit drained. And I think it's important in those days to look back and think of how far you've come and the impact that you've had so far and just not let it get to you because we're all human and we all make mistakes. So I always try to just do my best. And I've developed my own habits like exercise meditation that help me on a day-to-day basis.
I want to ask another question, which is you joined OpenBCI at a time when remote work became the norm,
Yeah.
right? So can a company like OpenBCI be a remote company?
It was challenging for us to go fully remote, but it wasn't as difficult as we expected at first because OpenBCI already had some people working remotely. So we have people that work from Europe and from other parts of the States. And that had given OpenBCI some practice in how to manage the operations and even some of the engineering remotely. But we're still a hardware company and we build a lot of the stuff in the office. So having the whole team remote was definitely a challenge that pushed back a lot of the hardware timelines at the beginning. But in the end, we came out stronger and we've actually doubled the team this year. So I think it proved, and also for me as a new hire, it gave me the confidence that the company is flexible enough to be able to find solutions when situations like this arise. So we worked remotely for a few months at the beginning of the pandemic. I think it was around maybe September or maybe October 2020, we started slowly to come back into the office because there was some hands-on work that needed to get done. And we implemented policies to make sure that health was being a priority. So only a few people were in the office at the time. We were all wearing masks. We took tests every day. If someone was sick, they didn't go into the office. They quarantined and stuff like that. So I started remote, which wasn't what I was expecting. But I think that in the end, it ended up being a positive for me because it made me realize that the team is flexible and whatever comes to us, we will figure out how to deal with it. There's
And
also a lot of companies that have stayed remote after the pandemic. So a lot of my friends just work from home. But for me personally, right now I'm doing a hybrid where I come to the office 3 or 4 days a week and I work from home 1 or 2 days a week.
okay.
Most of the team does that. So we're pretty flexible in that sense. But I personally like coming to the office because I like interacting with my team members. The conversations that I have with them that just randomly happen when we're in the office is something that I've learned from a lot. And I have a couple of people here that mentor me and help me to advance personally. So I think being remote doesn't always give you that opportunity. And personally, I like working in person, even if it means like getting up earlier in the morning. And obviously, some days I'm like, oh, I wish I could stay home and have more time. But overall, I prefer being able to come in person a few days a week.
And I was going to go into diversity in tech. As a woman in tech and within the hardware space, is it quite noticeable that there aren't as much females within the space that you operate in? or has this changed?
For me personally, it is quite noticeable. So I don't come across a lot of women in engineering. I ran a lot of the interviews for the engineering team when we hire people. And so I filter a lot of the candidates that apply. And I don't see many women in this space. I do try to do my part to encourage other women to join the field. So ever since I was at Surrey for the past like 5 or 6 years, I've been volunteering events where I teach young girls how to code or how to develop an app, and I introduce them to the field because I think that change needs to happen at the lower level, like school level.
Yeah.
I do think through events like these, it's improving because more and more females are getting into tech and are then giving back to the younger females and teaching them about tech. So I think it is improving, but I definitely see many more males in the field than females.
Yeah. And in your opinion, what are the effective methods that you've found actually attracts females into tech roles?
For me personally, having a role model is something that helps me as a woman in tech a lot. So having another woman in tech that I can look up to that is doing what I want to do in the future keeps me motivated. And also when I speak to them, they understand some of the concerns that I may have. So I think providing role models is an effective way to get younger girls to realize that they can do it as well. And it's one of the things that I try to do in these events, kind of just like be myself and show them that you can be a woman and you can work in this field. And I think another thing that I found has an impact is that when I was giving workshops, this was when I was at GE. So we actually led a few workshops and we taught young females how to develop mobile apps. And a lot of them weren't super interested in the coding aspect of it, but we tried to show them how coding was related to the other aspects of the app, how it had an impact on the design and how you could do coding. It wasn't only algorithms, it was also, for example, coding the front end, how the app looks, or maybe analyzing the data that the app was
Exactly.
producing. And, a lot of them didn't realize that you can actually use coding for all these things. They just thought that coding was just doing the math and that's it. And I think it's important to show that technology can be applied to many, many different fields. And, it's not, so it's important to show them the diversity of the field. And I think after those workshops, a lot more of them were open to the idea of doing like a basic, taking a basic coding course and then figuring out how to apply it in a project that they like.
You seem to be doing a lot in terms of bringing people together and exposing them to opportunities. And I need to mention the organization that you founded, Unipeers, right? So let's talk about Unipeers. What is Unipeers and why did you start Unipeers?
Unipeers is a nonprofit organization that I started back when I was at Cornell Tech studying my master's. And the goal is to connect students that are based in Europe and want to come to the US to do a graduate program with students that have already been through that process and that are happy to provide them with advice and tools that they used to be able to get there. So it's sort of like a community where you can connect with people who've done what you want to do. And the reason that I started it was because I had a lot of trouble finding opportunities to move to the UK first and then to the US. I didn't understand the educational system differences between the Spanish one and the UK one and then the US one. And I didn't really have anyone to help me. I just had to figure it out online. And eventually I figured it out. Now I'm here. But I think if I had had just one person to tell me the basics and show me, okay, this is where you can apply, and these are some of the scholarships that might be suitable for you. And this is how you can get a job after graduation. This is how piece of work. Even if they just gave me a summary, I think it would have helped me a lot. So I wanted to build a community so that people don't have to go through the same steps that I had to go to, and they can have it easier.
You reckon if you did have that guidance, you would be where you are much more earlier in your career?
I don't know if I would be where I am, to be honest, because I think my choice of universities may have changed. Like, I'm pretty sure I would have gone to Surrey because it was my top choice. And it's one of the best to go to for electronic engineering. And I really like the program. But when I came to the US, the Cornell Tech program was one that I like the most. And we can talk about it later on if you want. But there are also other institutions that I think I would have applied to if I'd known how the system worked. But by the time that I was filing in my applications, they had closed. Like I actually think I applied for my master like 2 days before the application closed. And it was all because it was taking me so long to figure out how to get a scholarship and the timelines and the visa. And even if it was feasible for me to come here. So I think if I had had help from the beginning, I would have probably prepared better. And who knows, maybe I would have ended up somewhere else. I'm glad I didn't because I don't know if I would have discovered BCIs, but I think it would have helped me to have someone would have made the process way easier.
Well, now you've created a platform that makes the process easier for other people coming after you. Okay. So in terms of the technical knowledge, could you get the role that you're in now with just a bachelor's and without the master's?
Yes, I think you could get the role that I'm in now without a master's, provided that you have enough hands on experience in the field to prove that you're able to do the work. But I think having done a master's gave me that little bit extra hands on experience because I got a lot of practical courses that I took. And also, it was during my master's that I got the flexibility to be able to work on a BCI project. So I think if I hadn't done that BCI project, I'm not sure if I would have got the job at OpenBCI because we do get a lot of applicants, and the ones that stand out the most for us are the people who've built their own things, just had the initiative to build something and like dive into this technology. That stands out a lot. So because I did that during my master's, even though it wasn't a direct result of the program itself, I think it gave me the time and the knowledge to be able to build that, which is then what impressed the OpenBCI team in the interview. I actually posted it on LinkedIn and the team found it. And at the same time, I was already like applying to the team, but it was my video that got their attention and they were like, "Oh, you made this." And I was like, "Yes, and I'm applying." And that got me to the interview. So
Wow. So, okay. So the side project you worked on got you into the interview, into the role that you're in now, but the master's you did gave you the opportunity to work on this side project. Okay. You also said you're involved in the screening of applicants, right? So are you trying to tell me that it will be more favorable to have, let's say, someone with a bachelor's with direct experience working with BCI than someone with maybe a PhD?
it depends, totally depends which role you're applying to.
Okay.
So we currently have a role open, which is the neural data scientist. And for that role, we require a PhD.
Wow.
It has to be someone that has a PhD in a related field and some practical experience with the technology. And for that role, we would not hire someone that hasn't done the research, no matter how much hands-on experience they had, because the stuff that they're going to be working on is directly related to research in the
Okay.
topic. And they need to be able to write papers and like apply for grants and things like that. But if you're applying for an engineering role, for example, personally, I value hands on experience quite a bit because it shows that the person has the initiative to take on a project and do it because they're interested in the field. It's not just that they took a class that they had to take because they were in the program. It's more that they wanted to build this. So they made the time to do it and they put in the effort. And two, here we're still a small company. There's a lot of things that we come up with that we want to build, but we don't know how to do it. So we all have this mentality of we have to figure it out. And we look for people that would be able to come in and kind of hit the ground running. And whenever we give them a problem, just have the ability to problem solve and figuring out what kind of technology can I use for this and how do I make it work. So I think by doing hands-on project, you get a lot of that you wouldn't get from the theory. But obviously, you still need to have an educational background that provides you with the foundations. Otherwise, you wouldn't know how to use the tech.
When I started this conversation, right, I knew it was going to be a very interesting and insightful conversation. But we've spoken about education, spoken about your background, education, and your career background. We've spoken about the future, about brain computer interfaces. We've touched on a lot of things, and I've learned a lot. And I'm excited. I'm excited to do the cinematic experience I was talking about. I might just create something there, maybe put a patent for that idea. But I'm also excited for this future that you're building, your team is building as well. And the focus on making it very affordable and also open is very important. So we can, people like myself that are hobbyists or we might have spare times can actually interact with the platform and create some cool things. Who knows? Is in there's so many ideas that I can think of, crazy ones. The work you guys are doing at OpenBCI is definitely at the forefront of the future, and it's a leap into how humans will be interacting with technology. I'm very glad we had this conversation. Do you have any questions for myself? Closing questions?
I'm very happy that we had this conversation as well. And thank you for having me on your podcast. I think another great way to advance the field is by doing the things that you're doing. So, giving exposure to people like me who are working in the field and giving us an opportunity to share with other people what we do, because hopefully someone else will come across this and think, oh, that's something cool. I'm going to look into it. What is a BCI? And then that person will eventually end up working in neurotech and be, it'll be one more person that is trying to move this field forward. So I appreciate you giving me this opportunity. And I guess one question that I have for you is, from all the podcasts that you've done, what are the top 3 things that you've learned that you found the most interesting?
Oh, top three. Okay, I could give you one right now, then I can think about it over two. The first one is the path that you think people have taken to get to where they are is not usually what you think. Basically, when you see people on LinkedIn that are in these high positions or doing this crazy things or this cool things, and you think, wow, they must have done this, a PhD, a master's, they must be so smart. It's not really that. These people are like normal people and they just work hard. And there's a very massive aspect of luck involved. But if you work hard enough, you will eventually be lucky as well. But a lot of people that I've spoken to are very hardworking people and they have high level of persistence and they persevere. They don't give up easily. So let me think about number two. Everyone is working on something amazing. Is in people like yourself, is in you're working on this, like what I see in movies, you're working on basically is in, which is very cool. So I've spoken to people that are working on language models, people that are working on other aspects of data science and machine learning that might not be hardware, but it might be maybe focusing on soft skills. But everyone has a story to tell and everyone is doing something amazing. And you can find inspiration from different places in this field. Like every time I speak to someone, I feel like dropping what I'm doing and start doing what they're doing. I'm like,
Oh,
that is so cool. Can you talk
have
about,
you got to get into neurotech?
as in, with the idea, the cinema idea, I'm telling you, Eva, in 10 years' time, the cinema experience is going to be very different. And I will be the front runner of it. I just need to think of a company name. So the first thing I found is everyone is actually accessible. Everyone is accessible and everyone is very friendly in this field. So there are a lot of people that have thought there's no way that we want to talk to me for an hour, but people are very happy to talk to me for 5 hours. Is in not 5 hours, you'd be very bored, but at least over the hour. And I always think, no, it's going to be hard to reach out to people, but people are friendly and people want to talk, people want to tell their story and people want to be heard. So that's what I'm here for. I think there's so many other things, but I have to have like a very good think of it. But those are three.
I like them. I think they're good lessons, especially the first one gives me motivation to keep working hard
Yeah,
because I also feel the same as you when I look at someone's LinkedIn. I'm like, whoa, how did they do this? But when you speak to them, you realize how they did it. And a lot of it is hard work that you do every day. And that might not have results on the same day, but it will have it over time.
exactly.
And you're able to look back. I look back on my time at Surrey, like how much I was studying and the time that I was putting into my side projects that I thought, why am I even doing this? Like, is anyone going to look at this project on my website? And then it turns out that those are probably the things that have helped me the most. So I'm like happy that I did it. But nowadays, with the things that I do on the side or some of the smaller projects I do, I feel the same. I'm like, why am I doing this? But I know that in the future, I'll look back and
It
be like,
pays
okay,
off.
that's why I did it.
Yeah, as in same here. Like at my time at Sorry, most things I did was write articles, right? And at first it was almost like not painful, but it took a lot of the time from the actual studying. But now it's paying off. I still write articles to today. And a lot of people have reached out to me through my articles, and it's provided me a high level of visibility, which I basically have taken advantage of. But I have one last question. This is the last question. Who should I speak to next on this podcast?
Oh, that's a deep question. I think if I had to choose one person that I would like to hear the answers to some of the questions that you asked me today would be Elon Musk.
Okay.
If you can speak to him, let me know. I'll watch the episode. I would be very interested in hearing his opinion on the future of invasive BCIs and whether some of the things that you talked to me about are possible or not.
You set the bar very high, Eva.
Well,
You set it very high.
shoot for the stars.
I did say people are accessible, but I don't think Elon Musk is. But we'll try. I'll send him a link.
You never know. You told me that you think
It's true.
people are reachable. So I think you should go for it. Just try it.
We'll try that. It's been a pleasure having this conversation. And thanks for joining me on this podcast.
Thank you for having me.